This is the machine learning process. First, we get data from one or many data sources like databases, web scraping, CSVs, sensors, or more. A quick terminology explanation before step 2. If we are trying to predict y using x, then y is equals to label and x is equals to features. We can have many features for a label. In step 2, we clean and prepare data which includes but is not limited to removing unrequired features or features that have no effect on the label, converting feature values to more programmable terms, for example converting yes and no to 0 and 1. Step 3, creating and training model. We can easily create model using Tensorflow, which we'll see live in a project in a few seconds. Step 4, we then test the model that we have generated in step 3 using the test data. We check the loss, and if the predicted output is not close enough to actual output, we then continue to step 5. Step 5, improving. This can include a lot of steps, but most commonly we tune hyperparameters. What is hyperparameter? Hyperparameters are those parameters whose values is used to control the learning rate. For example, it can be batch size, it can be epoch, it can be number of neurons, and more. Step 1 and Step 2. First of all, I've imported some very useful libraries that have made machine learning a lot more easier, like pandas for data reading, and matplotlib for data visualization, and TensorFlow for modeling and training. I have data locally here in the form of a CSV file, but you can directly put the URL of data source here too. First, it's necessary to know the data you have at your hands. Using pandas, I can see the overview of data quickly using the head function as I've done here. No need to open CSV in any other software. I can now see the details of the data using describe function of pandas. Using just a function, I can see important things like minimum of the data, maximum of a data, median, count, and more. Just from this, you can make a lot of judgment about the features in your data. I can use matplotlib to visualize the data that helps me to understand the correlation between features and labels in a better way. Here, I have used scatterplot to plot total bedrooms versus house price. As you can see, it doesn't look like there's much relationship between the two. I'm going to use total bedrooms to predict the price anyway, and we'll see what we can do to improve this in the last improvement step. Step 3, creating and training model. It might seem daunting to hear those terms at first, but we've come a lot far from doing all that ourselves. Thanks to Google, we can do it quickly with just 3 lines of code, as I've done here. I have created a sequential model with just one layer with one neuron to begin with. Remember, the simpler your model is, the better it is, and yes, that is a genuine way to judge a model. I also use mean squared error for calculating loss for this model. It's not as hard as it sounds, right? And it's the same with training. I just choose some parameters like batch size, epoch, training data, and train the model. If you want me to create an in-depth tutorial explaining all those things, let me know in the comment section below. Probably, it's difficult to understand all these terms and concepts than to actually start coding. Note that I said start, this code overview is actually just a start. After the functions to create and train the model are ready, I create another function to just print and plot the training process and the loss. And then we just call those functions. Here you can see the output of the function that we have created, and this is the plot. We can see the loss reducing as the training is progressing in the graph. It is a nice visual tool to see how the loss is reducing. We can use it to figure out the appropriate learning rate. Step 4, testing. Now to the exciting part, and also the disappointing part for beginners. It's time to make predictions. I've chosen to predict prices of 10 houses from the data using our model that we trained in the previous step. As you can see, it's pretty bad. And if it wasn't bad after so little work, then everybody would be doing this, wouldn't they? LOL. Step 5, improving. Since our model sucked hard, it's time to improve. First, I try to change some hyperparameters and pick another feature and see if the results improved. I've chosen here population instead of total rooms. It didn't, it sucked harder. As you can see, the predicted prices are far off real prices. So now, let's create some hybrid synthetic features from 2 features. So I've created a new feature, room per person, using total room and total population. And as you can see, it still sucks, but not as much as when we used population feature. Finally, doing something that good people do to begin with. Actually find the correlation between different features and labels. You'd think this must be a little harder, but it's not. It's just another function and we have correlation between all our columns. From this data, I can easily figure out that correlation between income and house prices is the highest. So I tune hyperparameters a little more, use income as a feature to predict house prices, and as you can see, the result improves a lot. But not to misjudge, this still sucks ass and this would never see the light of day in real world. But you will. I have faith in your abilities. In this way, we can do a lot more with our data until we have an acceptable level of loss. But overall, this is the flow and this is the process that we follow when creating a machine learning project. Let me know if you'd like to see me make this model kick ass and not suck ass. Till next time, peace.